All right. Hello, everybody. Welcome to another episode of React Wednesdays. Yeah, one of the guests was just telling me they dig the music. I always dig the music. I'm just sitting here dancing to it, but it's sort of anticlimactic when it ends. Like, I feel like I need a full wrestling intro. I need to come in running from the back to just maintain the hype. But this is hype. This is React Wednesdays. If you are new here, this is a show that we run every week here on the Code It Live Twitch channel. Basically, we bring in cool people that are doing cool things from around the React world. We talk to them about something interesting, or we have them show us something interesting. If you want to learn more, it's telerik.com/react-wednesdays, which I'm going to toss in the chat. There are links there. You can add the show to your calendar if you want to be notified of upcoming events, or if you just want to add individual episodes, you can do that as well. Next week, we're going to be talking about DOM APIs, which is not something you often talk about in the React world. So I think that should be a lot of fun. So check that out if you are interested. But today, our guests, we're going to be talking about rewriting a JavaScript library that runs on a whole lot of devices. And to do that, I want to go ahead and bring in our guests here. We've got Netto Farah and Puya. Why don't you guys tell us who you are, what you do, all that sort of thing to get us kicked off here.
Yeah, of course. I was the one complimenting the tune. I think that intro tune's really cool. Helps us ease in a little bit to the podcast too.
Yeah.
I'm Netto. I'm Netto Farah. I'm a software engineer at Segment. Been with them for about 5 years now. I've been working with JavaScript for about maybe 15 years, multiple generations of tooling, and working on Analytics.js was like one of the highlights of my career. And I'm very excited to tell everyone about the approach that we took, the problem that we were facing, and some of the really awesome results that we saw.
Cool. Hey guys, I am Puya, engineering manager for Segment's libraries and SDKs team. I joined Segment a little bit more than a year ago, and I've been doing JavaScript for around 10 years. Have been a JavaScript developer before switching to being an engineering manager. And similar to Netto, working on Analytics.js and rebuilding that has been one of the highlights of my career. And excited to be here to talk about it.
Yeah, so maybe one of you guys could start by just like briefly overgoing like the story behind what you did, and maybe even to just kick us off, like what is Analytics.js? It's a pretty popular library, but I'm sure there's people that haven't heard about it, what it does. So maybe we can start things there.
Cool. Maybe I can give a little bit of background on that. So Analytics.js was the starting point for a Segment as a company. It was a JavaScript bundle that provided a single API to collect analytics data from different websites. It was basically posted as an kind of a open source project on Hacker News back in 2012. And that was how Segment as a company was started. Nowadays, basically, Segment's offering is larger. It kind of provides a single API to collect all sorts of customer data from various sources. You can think of website, mobile, server, and send those data to different destinations like analytics tools, email marketing, push notification, advertising, whatever you can think of, even like warehouses. And beyond that, the kind of Segment started working on different things like protocols, running data governance on the data that you collect, as well as a big part of Segment's offering, which is personas, how you can stitch identities of your customers from different sources and create audiences and so on. So Analytics.js is kind of the first point of entry into Segment's platform, and it is Segment's SDK for collecting data from web sources. And that's AJS.
Yeah. On the more, I guess, like on the more technical side, it's an SDK that you include on your website, and with that, you get an API for you, a normalized API for you to start collecting analytics. So if you're instrumenting, and when we talk about Analytics.js, we're talking about anything that runs on like a JavaScript browser. It could be mobile web, it could be a regular website. And we'll talk about browsers too in a little bit, but like imagine every single permutation of browser under the sun. Imagine like, you know, the Nintendo Wii browser is like, could be collecting analytics on the website, and it could be running analytics.js. It could be a smart thread mill in somewhere in Amsterdam. I actually met with a developer once who was using some libraries for like this. I think he was building a smart treadmill and a rowing machine that were like running JavaScript. So anything could run JavaScript. So anything running a browser could be running analytics.js, and there is a good chance that it's running on analytics.js. So from like a developer perspective, it's having that API that allows for you to normalize how you do event collection. At the time in 2012, when analytics.js first came out, it was a way for you to just standardize all of your tracking across things like Google Analytics or Mixpanel, Amplitude, any of those all the tools that you were using before analytics.js. You would have to come in and like import the SDK for each one of these like analytics destinations and do your own instrumentation. With analytics.js, you do your instrumentation in one place, and you do it in a standardized way, following an analytics spec and like a set of methods. And then from there, all of your data is normalized and delivered to those destinations.
Yeah, and it's interesting to me because so 2012, that is in JavaScript years, that's an eternity, right? Like the JavaScript world just had like 3 revolutions in that amount of time. And I'm guessing like back then, our expectations were if I'm going to use like some sort of service, they give me a script tag. I like toss it on the page. I think nothing of it, right? I've probably got 7 other script tags I got there, right? It goes into production and life is great. But since then, I feel like we've become way more cognizant of things like the performance implications of scripts like this, usability, like, right? Like I just can't take a regular React or Angular app. It's not quite so simple for me to just like drop in a random like script tag, or at least I have to think more about what I'm doing. So is it, because we wanted to talk about rewriting this. I'm guessing some of this is like, this was a service that was built for initially 2012, but the world has changed since then, more or less.
It's fascinating just to think back that it's like just how many like generations of tooling, and even if you think just like in the bundling space, Segment wrote its own JavaScript bundler back in the day. That was like a real pain for us. It's like figuring out all of those, like how you're going to package up all of these different destinations and packages. You look like we've been part of like so many transitions and like innovation for all of these things that came in like this past like maybe 10 years. When analytics.js supports require.js, it was compiled. It used to be compiled on Browserify. It's now compiled on Webpack, but it also still supports all of these like old generation. It's like when you think of like analytics.js circa like 2012, it's like we didn't even have promises. So we're talking like callbacks, and it's like that's even like before like generators and all of that other stuff. And we are also back in the day when even Internet Explorer was a lot more relevant in like on the world stage.
So I'm curious, what was the like driving factor behind the rewrite? Because obviously software developers like always want to rewrite everything pretty much all the time, but like was there a business push, like were customers starting to complain and say like, hey, we want this to be like a more modern architecture? Or like, I'm curious, what was the thing that like pushed it like, yes, we need to tackle this and go about doing it?
Yeah, I think there's kind of like 2 parts to the story. There's like, I think Puya can tell a much better story on like the customer and like the pull and like the, the customer pull that we were seeing on one side. And then I can get on like the technical reasons why we thought this was going to have to be a full rewrite. And I can explain a little bit of like the architecture of the previous version of analytics and how it evolved like organically into what it was, and then what the steps that we took. But I think like, going through like the customer pull first probably makes a little more sense.
Yeah, I think from the customer side, we started seeing some trends basically with the popularity of running lighthouse tests. customers started running Lighthouse tests on their website and seeing that our analytics.js script is relatively a large bundle of JavaScript compared to the rest of their assets, especially given that it's added to the header of the page. It always shows up as an individual script on the Lighthouse test. As well as the performance, it wasn't optimized for the modern JavaScript, where you want to kind of deprioritize analytics works as opposed to your other things that you run on the main thread. So it always shows up as a thread blocking asset as well. So some customers who were very cognizant of their performance on their website started flagging JavaScript, or basically bundle and saying that, hey, improve the performance of your library. That was kind of the driving force from customer side to make a refactor. And I think there were other issues from dev experience that Netto can talk about as well.
Yeah, so then maybe to segue a bit to the technical side, I'm guessing then, like, what caused it then to be like a rewrite and not like, let's just trigger or like, you know, tweak what we're doing to make it slightly more performant?
Yeah, of course. So let me just like preface that with a little bit of thinking of an explanation here. Is imagine that like we're evolving this library all the way from like 2012. This is like pre-bundlers, pre-transpiling, like arrow functions, decorators, promises, and all of these things. That's like even like pre-browserify, so even like packages were installed in a different way. I don't know how many people are familiar with like this notion of like components, of like having a component JSON definition for a JavaScript package. That was like way back in the day, and we were super involved with like that trend too. So when you start to think, like, you start adding it up, right? So there's a company that just finds product market fit with this one tool, and then files, like it starts just like they just hit gold. So we just want to like rush in, like start you know, mining that gold and like figuring out what customers want. So imagine there's like, you know, years of functionality, features that worked, features that didn't really work and then had to be removed, or maybe, but because you have billions of websites, there's a very high likelihood that someone's using it. You start like, you integrate with things like jQuery, you integrate with things like prototype.js. You just expect them to be on the page, because at some point during those like 8 years that this library has been around, it was just part of building websites. You would just expect jQuery to be around. And then there were like other things, like you were, I guess, like bringing all of this legacy over the years, and it's just, you're just building and building and building on top of it up until the ecosystem has like reached maturity on, because imagine that it's like, this is one of the most important pieces of your architecture, and the ecosystem around it is moving, and it's moving really fast. And you don't really know which ones of like the new technologies that are going to stick and which ones that are going to make sense long term. So you're basically just like watching and waiting for the ecosystem to reach a level of maturity, which I think was maybe probably like just a couple of years ago that I guess like the community settled on things like React, we settled on Webpack, and I think I saw some like previous episodes of React Wednesdays, and I saw one on Snowpack that was really awesome too. So even though like we have reached stability, the ecosystem still changes a lot. So we're bringing and like piling all of these things on this library, and of course it's going to keep growing, and it's going to grow and grow and grow, and you're going to still keep writing some defensive code for every single permutation of browser. And this is also pre-TypeScript, so you also don't have types. And one thing that I think was particular to the architecture that made it really, really hard for us to keep evolving it is that this is also pre-HTTP 2. So back then, you also want to optimize for the number of requests that you make on the page. So analytics.js was completely optimized to be one request and one request ever. But in order for that to work, you need to bring the tracking configuration alongside with the bundle. So for example, if you set up a segment.com account, you go in, you set up your workspace, and you decide, it's like, oh, I want to track these events and I want to send them into these like 5 or 6 different destinations. And I'm going to roll them up with like some settings for my destination. So say that you're using Google Analytics and Amplitude, you also need the API keys for each one of those. So our previous architecture would just consider all of that data. It would package everything up, compile a new version of Analytics.js for this one specific customer. And that one bundle would contain your Google Analytics code, your Amplitude code, your API keys for all of them. And then you end up with like just this one little package or like this one big package that you end up shipping in the UI. But of course, that sort of like architectural decision, which made a lot of sense at the time, given the constraints, it starts to like build up. It gets like really complex once you hit critical mass. So we have thousands of customers that are running analytics on like billions of devices. You're constantly rebuilding that bundle. So you imagine like the cost of rebundling everything all the time. And tree shaking becomes super challenging as well, because this is we're dealing with like pre-tree shaking technology. So you're always shipping all of this code, and before you know, you're shipping 500K of JavaScript into a website.
It's funny how expectations change, because as you were going through that, it's like bringing back memories. And like, I don't know, like 2014 me would have saw that and been like, that's awesome, right? It's just one thing that ships. Like, that's a big positive, right? That probably is going to make me like choose a solution like that. Fast forward a few years and all of a sudden it's like, oh, that's all packaged together. And it's like that much code. Like, that's a horrible design decision. It's just funny how these expectations change and what people are looking for.
Yeah, and when you think like modern JavaScript, like now you have things like you have HTTP 2, so you can make several requests if you want. We have a HTTP 2 server push, so you can even push resources in advance. You can do things, you have promises, so you can write your entire code and like you can design your code to deal with very easy async constructs, which we also didn't have at the time. But like when you do, that means you can load separate bundles in with a promise through like a script tag. You can do things like Webpack bundle splitting and all of that stuff. And then just having these constructs give you so much more. It gives you so much more tools that you can use to build so many more. So yeah, what triggered the rewrite was really just like looking at the architecture and seeing that it didn't really age that well in the current like ecosystem. Like, and especially when Puya mentioned Lighthouse, you look at like the Lighthouse metrics, and man, we spent hours and hours and hours staring at like several Lighthouse scores and tests for all sorts of websites that you can imagine, and to the point where it's like it's all ingrained in my head now. I know the metrics. You're looking at unused JavaScript, you're looking at number of requests, you're looking at cache length, you're looking at all of that stuff. And when you look at the architecture for Analytics.js, you see there's like, oh yeah, we have none of that. We can't cache the bundle for too long because it brings a lot of configuration, and it brings like control plane concerns into it. It brings some data concerns with it. It brings a bunch of bundles. It brings a bunch of libraries that are backfilling super weird behavior in all of these bizarre old browsers. And so you don't get caching, you get a massive bundle, you have to put it in the head, and before you know, you're breaking all the rules of Lighthouse. So that was a big motivating factor for us. We detected that shipping a massive bundle was one of the main challenges that we're going to have. So that, to a point, just kind of convinced us. It was like, okay, it's just the perfect storm of things. Like the tooling ecosystem is super stable. We can bet on things like Webpack. We love TypeScript. We've been using TypeScript at Segment for years now, and it's to the point where I think most of our JS code base is now TypeScript. And so our developers love it. Our deploys are too time consuming, and the library is not very performant. So now we have all of these constructs that we can use, and that just triggered some exploration into like what a rewrite would look like.
Cool. Yeah. So then I'm curious, like, so you've made this determination, you need to rewrite this. So I'm curious some of the decisions you made, like, because it is fairly liberating, right? Like that had to have been a fun day where you're like, okay, now we have a blank slate and let's do this. So for solving all these problems, maybe you could walk through like some of the architecture of what you went with, because it is pretty fun to talk about like pie in the sky, like how you would architect something like this with 2021 tech.
Yeah. So to preface, like one of the things that I really love about our culture at Segment and our team, and like working with folks like Puya and other folks on my team, is just that Segment really encourages engineers to take risks and to experiment with things. So this all started out as just a spike, as a prototype. We, like Puya and I were chatting, and with our PM Osama too at the time, we were like bouncing ideas off of each other, and we're like, okay, but why don't we just try and build something, and let's time box, this little project and see what like the perfect architecture of AJS would look like. Not really perfect, but like what's the best that we can build. And one way that I particularly like to think is like, I like to remove all the constraints when I'm thinking of like ideas. It's like, I'm not going to think too much about like the existing API surface or how many customers we have or all of this stuff. I'm just going to think it's like, where can I go from like a no constraints like world? Like what could I build? And then I'll time box it. I'll say I'll give myself like a budget of like 1 week. What would the perfect architecture look like? Try and build it, and then I'll try and reintroduce all the constraints. And that's basically how it went. I wrote a prototype. I started presenting and like evangelizing it to folks. And one thing that I think was also really important, that I think is one thing that Segment, the engineering org at Segment does really well, is that we have a culture of writing things down. So I wrote down all of my assumptions at the beginning, and then I wrote down all the things that I proved or did not prove with my prototype. And then eventually that turned into a big document where I'm advocating for a full rewrite. And but now with just 1 week of experience under my belt, I can actually predict that feature like with much more certainty than I could before. And then we had this document that was basically talking about like, how did we get here? What are the things that are working? What are the things that are not working? And this is the plan that we have to make all things work. And we started like evangelizing this doc, and I was like sending it around. We love using Dropbox paper. And so I wrote like a big paper doc with the vision that I had. And then we started sharing it with everyone. And it turns out that everyone was excited about it, because everyone had been experiencing the pain of the old architecture.
So I'm curious how you deal with some of these problems we discussed, like file size, because I know you had said you did a little bit in terms of just modularizing. So I'm curious, like, what approach you took to that to split out, because I imagine there's like some sort of core of analytics.js and then like a laundry list of things that people might or may not use. So I'm curious how you tackled that.
Yeah, that is the most exciting part, is that we applied some like, it was really some 80-20 thinking. I was looking at like, what are the things that caused like most of the flaws or most changes, or like, and we found that it was really the core issue was the big bundle. It was bundling everything together, and you're always recompiling your entire code base when there's a minor change. So imagine that you have things like the Google Analytics implementation, the Amplitude implementation, and the Segment core implementation. You make a change to one of the libraries, and we had like 250 partner libraries that are changing all the time. And then you're recompiling analytics for everyone who's using that library all the time. So I noticed, okay, the core never really changes. We almost never touch it, but the libraries change all the time. So we should probably split them apart. And now with things like bundle splitting and HTTP2 and promises, we can do all of that stuff really fast. So one of the things that we did was like, we rewrote analytics as just the core. It's just an event pipeline that is issuing new analytics like event calls, and then it's pulling all the partner destinations on the side. So it's side loading Google Analytics, it's side loading Amplitude, it's side loading Full Story, any of these partners that are connected in the Analytics.js ecosystem. So the moment that you do that, it means you can cache all of these things forever. So if if our Google Analytics implementation only changes every 6 months, then we can cache it every 6 months, or we can cache it forever, depending on the strategy that we use. And the strategy that we ended up doing was like, we have a mono repo that contains all the destination code. And this is actually public. If you want to visit it, it's on GitHub. It's /segment.io /analytics.js-integrations. We can if you can post it to the chat. Yeah,
put it in the private chat. I can pass it along.
Yeah, so if you'll see that each one of those is now like a separate package, and it's deployed on its own. And then we leverage things like Md5 hashing. So one of the things that we did, which is it's very common in Webpack, it was very common with the Rails asset pipeline as well, is that you can calculate a SHA of not a SHA, like the MD5 of the contents of the file, and then append that to the file name, and then deploy that and keep it forever, because the file never really changes. So if the file changes, then the signature of that file also changes, the file name changes. Then what we did is that we have a manifest now that is basically just a JSON file that says, oh, for each module, this is where you should just go pull it. And
where is the user configuring which of these integrations they need? Is it like in a config file? Is it like in a query string? Where is that actually happening?
If you go into the Segment app, you will have a catalog. If you go to segment.com/integrations, you have like an idea how that looks like. But basically, you pick from a catalog of the things that you can integrate with your analytics stack. And then once you flip some switches, you enter some settings, and you're good to go. All of that stuff gets reflected onto your website for tracking. So that was one of the things that we did. We split the partner code from the core of analytics.
I see. So does everybody get the same like integration code that has like more or less like an account ID, and then on the back end you determine what sort of things that need to get sort of built into it?
Yeah, that's pretty much the way that it goes. And if you on Analytics 2.0 now, instead of shipping that entire bundle, we ship the analytics core that's very, very tiny now. It's 17 kilobytes, and it houses all of the code that you require to do analytics tracking. And then we pull all of these partner integrations on demand based on your configuration.
Okay. Yeah, and I think too, like, and I'm presumably like you do that instead of like build time, because people need to be able to like work in, like marketing people or whatever need to be in their back end thing and configure and tweak things.
Yeah, and that changes a lot. The delivery changes a lot too. It gets a lot faster because you don't have to rebuild all of these like hundreds of packages that we use to actually build the platform. So the platform changes very rarely, and the destinations are changing all the time, but you're caching them forever. So you only really have to download it again when there's a new version. And then when you look at like Lighthouse scores, it dramatically changes how your website interacts with analytics now, because the analytics bundle comes in very small, and then all of the other stuff is also very likely cached in your browser again for like a second visit. So it becomes almost instant when you visit a website. And then we did the same thing for functionality on Analytics.js, and that's what I think is one of the more interesting things, is that we went to look at like feature usage. So you know that like now that we've been building this for 8 years now.
This is analytics like, on your analytics. This is
analytics
very
on
meta,
analytics.
yes.
It's very meta. Yeah. And then so we know feature adoption because a lot of this configuration is done via UI anyway. And of course there's a level of instinct that goes into it too. So like we can always talk to people and figure out like what they're using, and you can also kind of guess. So we did a combination of all of these things, and we noticed that not every part of analytics, it's like not every single feature is used by most customers. So it's like classic 80-20 Pareto principle. You see that, 20% of your features are used 80% of the time. So that's also another awesome opportunity for performance improvements. So now that we're on super current tech that we can do all of this stuff, we identified all of the points, all of the entry points in analytics that were not super like used all the time. So for example, we have this feature that's called Middlewares. Like middleware has been around for only a couple of years, so not a ton of adoption. It's also not, it's useful for some like very specific use cases, but not for the general use case. So that looked like a perfect candidate for like, okay, let's put that in a separate module as well. And we used Webpack bundle splitting for that, and where you can instruct some part of the code to say, hey, when you do this import, do this with this chunk name. And you're basically telling Webpack to like, hey, when you compile this bundle, compile this module and all of its dependencies as a separate thing, as a separate entity. Also hash it, put the version of like this change, and then deploy it as a separate thing. So you can imagine that like when you're loading analytics.js, it will start pulling features as you start using them, which is really cool. So if you're a customer who's using middleware, the first time that you invoke a middleware function, it will go, analytics will know that it's like, oh, okay, someone's using this feature that not a ton of people use. So I'm just gonna go fetch it from remote, set it up, enrich my core library with this feature, and then move on.
So how does that work then at runtime? Because like, yeah, presumably you're actually like fetching, like making it like an HTTP call for this.
Mm-hmm.
And it's been a while since I've done this. So I'm actually curious, like, how do you then, I'm trying to remember, like, how do you integrate that code? Are you still like, is it still like eval? Is ES modules? Like, I'm kind of curious how that actually works nowadays, because I haven't done this in a while.
Yeah, so it's kind of a mix. So we still have to support a bunch of browsers. So we're not doing anything too fancy. So under the hood, it really is just a script tag. So everything is built as a UMD bundle. So you download the first initial bundle, and then because everything is behind promises now, you can, so for example, a track call or collecting a page view, it's all done through promises. So you start on, for the end user, it's completely transparent. They're just dealing with a promise. They're just awaiting on a promise. But say that you're issuing a page view call, you await on it, and the page view code detects that it's like, oh, I'm missing some functionality here. I'm missing a package. I'm missing something specific. I'm going to create a script tag. I'm going to put the path in there. And once it's loaded, I'll inject that code back into it. It's a lot of like, it's almost like meta programming in a way. So you're enriching prototypes, you're like you're fetching bundles all at runtime, and then you're enriching your code, and then you're using it, and then the browser knows to take care of it. Eventually, like all of this stuff is cached for like a year. So the browser knows now the next time that the functionality is already available. And to me, it's why I love promises. I think it's like one of the most powerful constructs in the entire JavaScript ecosystem. It's just that it lets you abstract things like this. It's like, oh yeah, this thing will block. We'll do, well, not really block, but like this thing will be done async. And once it's done, it will come back, and then you'll be able to use it. And it doesn't really matter what it does under the hood.
Do you have to worry about like busting the caches? Like if feature X changes and you had a cache for a year, how do you tell the browser it needs a new version of it?
Yeah, so the way that this works, and Webpack does that automatically for you if you're using bundle splitting. But the way that this works is that instead of caching everything, you only cache things that are on, if you imagine that as a tree, right? There's the trunk, that's your core of your library, and then there's all the dependencies.
Yep.
You can cache the dependencies forever, so long as you keep a manifest in your trunk that tells you where to go to fetch a specific module.
Oh, interesting.
So the architecture that we use is like, we never really cache the core. I mean, we cache it for like 5 minutes, and then this core of the library, it knows where to fetch each one of its dependencies. So yeah, if the feature changes, then the file name changes, then the manifest changes, and you would know where to go pick the new one.
That's interesting. I like that a lot too, because then it mitigates having to like deal with the browser cache and all the like potential bonkersness that comes with dealing all of that.
Yeah, and yeah, Puya could speak about the distribution of like how we roll out, and I suspect you would want to get into like quality and like shipping too, and like the continuous delivery story.
Yeah, go for it.
Cool. Yeah. So mainly we use basically AWS for our delivery infrastructure, and we have a technology behind the scene that creates all these bundles, put them on S3 bucket, and then we have a CloudFront distribution in front of it that delivers all the bundles to our customers. As Netto mentioned, the core, which is super small, is cached for a limited amount of time. So as like if we make a change to that core, after 5 minutes or so, a user gets a new version. And then that core contains a manifest that points to all the bundles that needs to be downloaded. And also, of course, we have some tech under the hood that makes sure we can push specific versions to specific customers. So each customer can get their own core with their own customized manifest that basically gets them the right version of either the core or all the destinations that we build. And again, with this model, the caching is super efficient. If you look at the old version of AJS, the whole 100 to 500 kilobytes of JavaScript was only cached for 3 minutes. And then after that, the user has to re-download the whole thing. Now the user has to download the core, but all the destinations are cached infinitely. We basically even mark the asset as immutable. So we tell the browser, this asset will not change. If it changes, we serve it using a different hash or different version. Therefore, browser can cache it infinitely and super efficient from caching perspective with this new architecture.
Actually, how big is the core now? You said it was like hundreds of kilobytes before.
I think around 17 kilobytes these days.
That's pretty good.
Yeah.
So one other thing I want to talk about is testing of this. And in fact, like the link I just shared, which in chat, you should totally check this out and click the integrations folder and just scroll through it, because I've been doing that and I've discovered like platforms that I had no idea that existed. Like some of them might even be fake. Crazy Egg,
That's the real thing.
Yeah, so there is a lot in there. So testing this, I'm sure, is potentially fun, right? Because I imagine it's fairly important to some of your customers that like even some of these niche ones actually work. So maybe we could just start by, you could tell me like some of the testing infrastructure you have for like making sure this stuff works. And I think I'm especially curious, like browser testing for some of this as well, and like what browsers your like the new version of your service supports also.
Yeah, I think to preface is that we still support Internet Explorer, but only IE 11. We don't support anything like less than IE 11 anymore, because it's basically impossible to achieve all of the performance improvements that our customers were asking for, and while still supporting IE 7 and 8, and even like their market share is just so small these days. But yeah, so we do, as you imagine, like we follow the test pyramid. So there's thousands of unit tests, thousands and thousands of unit tests that all run very fast, followed by some integration level tests above, and then you have a slightly fewer but more comprehensive full end-to-end tests. And we still try and test things in as many browsers as possible for any change, for any partner code, or any of our core functionality. So the core of Analytics.js has a very fast unit test suite that is running all of the unit tests for each specific module. That is all using Jest, and it runs really, really fast because it's the beauty of writing a JavaScript SDK. The thing I love the most is like there's no database, there's no user interaction UI, there's like none of that. It's the easiest and like most fun and exciting code to test, because it's really just a bunch of stateless functions that you pass inputs and get outputs on the other side. So that I really love. That makes it really easy to test at the unit level. All of our partner integrations that you posted the code to they're all tested individually as well. So you have unit tests for all of that partner integration code. Those are actually running on browsers. So we use Sauce Labs, and I think it's a mix of Sauce Labs and Chromium. So everything runs on Chromium first. That you just want to try and get like the test results as quickly as possible, all locally on your own machine. So you're running headless Chrome, it's everything running against it. And then each one of those individual tests also run against a suite of browsers in Sauce Labs. So, if you're not familiar with Sauce Labs, it's this really cool product that gives you browsers in the cloud. So you can send signals into these browsers, and they're all just running tests. So all of those run against Internet Explorer, Safari, Firefox, like the latest versions of each browser, plus IE 11. And then on top of all of that, we also have our integration test suite, which is really, really cool. And it's basically looking for inconsistencies across different versions of Analytics.js. So the way that you do it is like you assume that the most recent version of Analytics.js is bug-free. Yep. Just an assumption, but like you assume that a past version is bug-free and it's well-tested and it's battle-tested. And that happened over the course of years. So you can kind of trust that one, that it's pretty stable. And then on any new version, you will download every single destination. And we have credentials. We have a set of credentials for each one of those 186 destinations.
I was going to ask about that, because that seems like a little bit of madness too.
Oh yeah, it's pretty hard to maintain, but we have credentials to all of those, and we know that they're valid. So we pull all of those credentials. We pull all the partner libraries, and then we have a test website that is just basically HTML page with a form. And we spin up hundreds of as many processes and threads as we can, depending on the computer that you're running. So if you're running on a MacBook Pro, top of line, maybe you have some 16 CPUs that you can leverage. So that means it's there's probably at least 16 tests running at a given time. So that spins up headless Chrome with Puppeteer, injects that HTML, downloads two versions, the previous version that you're assuming to be good and the version that you're testing. They all start tracking events. And then we mock the network layer for both of these Chromes. So if you're using Puppeteer, there are APIs that you can write that I think is called the request interceptor. So you can write code that is mocking the boundary. So data is never really leaving the browser, and you're collecting an array of every API request that was made. So then you run both at the same time, and then you diff. You diff to see if there's any difference between the two. Of course, there are some tiny differences that you're going to have to account for, things like timestamps, but they don't really matter. Then you compare that the shape of the data is the same, the contents of the data is the same. And if that's okay, then you can just assume that they're working the same. And we have it for every major feature. We also collect all of these things. We see if it's acceptable. If it's not, then you pause the release, you pause the CI. If it's acceptable, you let it go through. And we have other things too, Sauce Lab tests that are just smoke tests. So for example, it's can this library boot on Internet Explorer? Can I call this function and not have the browser do anything, throw an error or anything like that? So there's also a suite of tests that's testing that at least the entry points work on every browser.
For your integration tests, what handles the parallelization, if I'm pronouncing that word right? Is that something a tool that's helping you manage that, or is that somewhat hand rolled?
No, that's so we're building everything on Jest, and Jest also comes with this package called Jest Workers, if I'm not mistaken. And basically, it's the abstraction that the Jest team built to deal with multiple CPUs. And I really love the isolation model that you get with Jest, where they're leveraging every CPU that's available through sort of a worker pool. So we use that package to set up a worker pool and then assign one test to each of the available workers So the way to think about it, it's like there's a buffer of like hundreds of tests that you want to run, and there's a number of available CPUs. And I love that we invest a lot on developer productivity. I think it's one of the most exciting things about working at Segment is that we know to invest in developer productivity, and that makes a huge difference. So our CI has like 32 cores.
Yeah, I was gonna say my next question was gonna be, does it turn your like laptop into a space heater when the test suite runs?
It does. I can barely even like scroll like in my browser or do anything. I just like leave it running, but it takes very little time. It takes like 45 seconds to run.
Oh wow. Yeah.
All of these permutations, and in CI it's even faster. And it's one of those like, it's trade-offs, right? And it's like these things that you need to balance. It's like, can you put a price on peace of mind? Can you put a price on developer productivity? It's like, yeah, even if it costs us like thousands of dollars a month to know that we're not going to lose customer data, man, give me 150 cores. Like, give me whatever many CPUs. If I can get my CI time to 2 minutes instead of like 2 hours, I don't know. If I'm the CTO of a company, I'm just going to throw as much money as I can, with the productivity of my engineers.
So, so speaking of peace of mind, do you have any way of like, when you push out something new to the library, and I'm asking this just because like I find the scale that Analytics.js operates at kind of fascinating. Like I've never worked on anything that like that hits a fraction of those many users. So my question is, do you have anything that like segments out, like if you need to push out a new feature so that only like X percentage of people get it, like, or is that a concern? Because like I would feel hesitant, no matter how many tests or CI servers I have in front of me, I would be hesitant to hit that button that sends it out to like everybody at production at the same time.
Yeah.
So I'm curious if you have any processes related to that.
Yeah, Puya can tell that story. It's fascinating. It's really cool. We deploy multiple times a day.
Yeah, I think we basically maintain these two versions, one a stable, one a canary, and we have some tech behind the scene that can deploy canary to certain kind of segments of our customers. So usually when we want to deploy, we first release a canary version, roll it out to internal segment sources, like all the sources that our engineers use and our engineering team uses and segment use internally on their website. After that was good, we start gradually rolling to percentage of user and gradually increase that percentage. And we basically have a feature flagging system that we build internally at Segment that is kind of the heart of this thing.
Are there ever any issues with like if you need to make a change to like the back end, does the back end need to know like take in like a version number to like or like to like branch potentially if there's like something breaking? Considering like so canary and stable, let's say they have to hit a back end slightly differently, but they're both going to be in production at the same time, right? So presumably the back end has to temporarily at least handle both until like the conversion is complete or whatever.
Usually the back end portion of Segment doesn't change that often, given the like size of the customers. We make our APIs relatively resilient to changes. So let's say if our backend slightly changes the signature, they try to be still backwards compatible in their APIs. So given that, we haven't had that issue before in terms of sending data to Segment. And I don't know, Netto, if you have faced something like that before.
Yeah, no, I think that sounds that all sounds correct. The thing though that I think, and from my perspective, the biggest architecture unlock and the thing that makes all of this stuff possible was really the 80-20 analysis that we did and realized that partner like destination code changes at a different pace and frequency as like the core of analytics.
Yeah.
So shipping all of them together is what introduced like 95% of risk. It's like it was really hard for us to coordinate releases because you're always shipping everything as a monolith. So you could imagine that you have multiple work streams. There are multiple teams. They're moving at a completely different pace. They have different goals. different functionality that they want to get out of the door. And all of a sudden now you need someone to like corral everyone and figure out a safe way to release all of these things, even though the contract has never really changed. So we noticed with this architectural change that it also enabled organizational change. It enables now that it's like, you can ship a very lightweight core of analytics that has a manifest that tells it what to do. You can do deploys as like really just changing that manifest. So one of the things that we do is like we run multiple versions of analytics for different people because they just get a different manifest file. So we have things like per branch deploys, similar to things that you can do with Netlify and Vercel. Is that you can push your branch and that generates a completely custom version of all the analytics destinations and modules for you. And then you can change that manifest file. It's like, hey, for Google Analytics, for me, for Netto on Google Analytics, give me this alpha branch that's like lives in this S3 bucket somewhere. And then all of a sudden I'm testing in production my own change, but it's not affecting anyone else.
This is really fascinating stuff. We have a few minutes left. I want to just remind chat one more time. If you have any questions, now is a great time to get those in so I can run these by these guys. I am curious, the old version of Analytics.js, how long is that still running? Is that something like, do you have a timeline, like how long that's going to have to be supported, or how does that work?
I think we are still figuring that out, but our goal is to deprecate that version or end of life that version as soon as possible. So mainly only doing security updates to our third-party modules and so on. And we are in process of rolling out AJS 2.0 to most of our customers. So last week, we actually upgraded a large segment of our customers to AJS 2.0 without any issues or complaints from our customers. And we are hoping to go through that process over the next few months. Eventually, our goal is to replace the old version with the new version because first, it's faster. Like it's better for our customers to be on the new version and they get a lot of benefits there, as well as for internal developer productivity.
Yeah, I feel like this always like plays a part in any sort of these rewrites is like how easily you can get rid of the old thing. Because I've also been part of some rewrites, not at this scale, but where the old thing, like the plan is to get rid of it after like a few months, and then it just lingers and lingers and lingers.
Like lingers forever.
Yeah. So I wish you guys the best with that, because that can be no fun.
Yeah, maybe one thing I can add that I'm really proud of the team that they did. The basically rebuild this way is it is fully backwards compatible. So the new AJS 2.0 is just a drop-in replacement for our customers, just a flip of the switch in the UI. There's no upgrade path. And I think that helps us a lot in migrating our customers or switching our customers from the old version to the new version.
Well, cool. I'm not seeing any other questions from chat. I think my last one for you guys is if people are interested in this, like where's the best place to send them? Where should they go if they want to try this out?
Use Segment, sign up for Segment, and create a new source, hook Segment to your website, and you'll get Analytics.js.
Yeah, we're also working on an open source version of all of the stuff that we talked about. So if you look at the links that we shared already, the Analytics.js integrations, that's already open source. That's just part of the story. It doesn't include the core rewrite of what we're doing, but we'll also have that publicly available soon too. And we're documenting all the decisions and all the things that we did. So we'll welcome community contributions as well. Yeah,
this is like, it's interesting stuff. I could see this being useful for others, like especially just how you handle the code branching and such. Could definitely be something others could take use of. So if people want to like keep up with you guys, what's the best place if they want to follow you and such? Where's the best place to do that?
I'm tweeting all the time. Follow me on Twitter right here. I'm always sharing stories about like the things that we're building, and we'll very likely announce open sourcing Analytics.js on my Twitter account too.
Netto's Twitter is the best source.
You've got some Twitter talent. I mean, it was a tweet thread that had us reach out to you in the first place. So. Definitely good
Can
stuff.
I say I like telling stories? Yeah.
Well, thanks, guys. This has been a lot of fun. I find it very interesting. It's not every day you get to work with a library that has this sort of scale. So it's always fun to hear some of the stories behind it.
So it's really fun. I could go on for hours.
Well, when you rewrite segment, or when you rewrite analytics again, when 3.0 comes out, we'll have you back on the show and we can talk about how Webpack's totally dead and no one wants to bundle split anymore, right? We'll look back at this and all of our current assumptions will be totally off.
I'm ready for that.
All right. To wrap up here, I'm going to drop one more time a link to the React Wednesdays show page. If you do enjoy this, just know that we do this every week. It's Wednesday. It's React Wednesdays, 1 o'clock Eastern. We bring in fun people. We do cool things. So thanks, guys, one last time. And I will see everybody next week.